Hello dear friends, welcome back to my YouTube channel. Now in today's lecture, we are going to learn about the calculations of formal charges in molecules or the polyatomic ions. Now in the previous lecture, we have studied about what is the formal charge, how we can calculate the formal charge and what are the applications of your formal charge. But here we are going to take another few examples so your idea will be clarified about the calculations of your formal charge. So before watching this video, I request to watch out my previous video about the formal charge and then come back and watch this video. Now let us start with the calculations of the formal charges with the first example, that is N2o molecule, which is actually that is nothing but your nitrous oxide. Okay. Now in this molecule we have to find out the formal charge on the both nitrogen atom as well as on the oxygen atom. Now to know about your formal charge, in the previous lecture you already know that we must know the Lewis structure of this molecule one. So first of all we will draw the Lewis structure of this molecule one. So the Lewis structure of N2o molecule is, we know that two nitrogen atoms are in the N2o molecule and one oxygen atom. So I will show the electrons of this nitrogen atom by dots 1 and the electrons of this nitrogen atom by cross. So here this nitrogen atom forms the triple bond with this nitrogen atom and this oxygen atom will form the single bond with this nitrogen atom. Okay, so we can again simply draw this structure like this: N with their lone pair of electrons, NO with the 3 lone pair of electrons. So I am going to mark this each atom in this molecule. So I am going to give the first number to this nitrogen molecule, second to this nitrogen molecule, and third to this oxygen molecule one. Now we can calculate the formal charge in this molecule one. So in the previous lecture you already studied about the formula for calculations of the formal charge on the atom one, and that formula is Fc, that is nothing but formal charge, equals to VE minus Ne minus 1 by 2 into Be. Okay, so this is the formula that we have studied in the previous lecture one. We know that here V is nothing but the valence electron which is present in the particular atom. Ne is nothing but the non-bonding electron which is present on that particular atom. That is nothing but the lone pair of electron which is present on that atom one. Then Be is nothing but the bonding electrons that are present on that atom one. So here we will use this formula for the calculations of the formal charge on the each atom one. So we will start with the first thing, calculation of formal charge on nitrogen atom marked as number 2. Okay, now we are going to find out the formal charge on this nitrogen atom one. Now here it is very easy. We know that nitrogen atom, what is the electronic configuration of nitrogen atom? That is 1s2, 2s2, then 2p3. So which is this valence cell? That is 2s and 2p will contribute to your valence. Now what will be, this is the valence cell. Now how many valence electrons are present in the nitrogen atom? We know that the electrons which are present in the valence cells are nothing but the valence electron. Therefore here the total number of, so I will write it as a total number of valence electrons equals to 2 plus 3 equals to 5. Okay, total number of valence electrons that is VE will be equals to 5, that is 2 plus 3 electron. Now the second term that we have to consider is the non-bonding electrons. Now you will observe this Lewis structure. Okay, now you can observe this Lewis structure. Now you will understand from this Lewis structure the total number of non-bonding electrons that is your Ne will be equals to. Now non-bonding electrons are nothing but your lone pair of electrons. Now if I find out how many lone pair of electron is present on this nitrogen atom, there is no any lone pair of electron. Remember, this is the bonding pair, this is also the bonding pair, but this is the lone pair. Okay, so particularly on this nitrogen atom there is no any lone pair, therefore non-bonding electron will be equals to 0. Okay, now next term that we must consider is your bonding electron. So let us find out the total number of bonding electrons, that is Be, will be equals to. Now here you can observe that the nitrogen atom forms the 4 bond. Is it right? We know that each bond is formed by the 2 electrons. So there is a 4 bond, first, second, third and 4 bond. Okay, the total number of electrons will be 2 plus 2 4 plus 2 6 plus 2 8. So total number of bonding electrons will be equals to 8. That's it. So we got all the values of this term 1. Now just apply formula. So by the formula, that is Fc equals to Ve minus Ne minus 1 by 2 into Be. Okay, so put the values for this nitrogen atom. Ve is nothing but 5 minus Ne is again 0 minus 1 by 2 into Be is nothing but 8. Let us find out the final answer, that is 5 minus 1 by 2 into 8, that means will be 4. That means 5 minus 4, as this term is 0, therefore 0 5 minus 4, that is equals to plus 1. So therefore we can write the charge on the nitrogen atom marked as 2 is a plus 1 charge. Okay, now in the similar fashion we can find out the charge on the nitrogen atom which is marked as a number 1. So let us find out the formal charge on the nitrogen atom which is marked as a number 1. So the calculation of formal charge on the nitrogen atom marked as number 1. Okay, now here again we have to consider the same terms. So we know that nitrogen atom, it is the nitrogen atom, so we already know the valence, total number of valence electron for your nitrogen atom. So just write down again total number of valence electrons, that is Ve equals to 5. Okay, now for the nitrogen number 1 we will find out the total number of non-bonding electron. The total number of non-bonding electrons, that is Ne equals to how many? Now here you can observe this is the lone pair of electron, okay, which is present on the nitrogen atom. So total number of valence electron in the one pair is 2, therefore its value will be 2. Now third term that we have to consider, the total number of bonding electrons, that is Be will be equals to how many bond is formed by this nitrogen atom? You can observe that 3 bonds. Okay, so we know that each bond consists of the 2 electrons, therefore 3 into 2, that will be equals to total 6 electrons. So again, by applying the formula, that is Fc equals to VE minus Ne minus 1 by 2 into Be. So we already know all the values, so just put up that value and find out the answer. That is 0.5 minus 2 minus 1 by 2 into 6. So that will be equals to 5 minus 2 equals to 3, and 3 minus 3 will be equals to 0. So the charge on this nitrogen atom is 0. Therefore the charge on the nitrogen atom marked as number 1 is 0. That means it is the chargeless molecule. So this is about the two nitrogen atoms. We can easily find out the charges on the nitrogen atom, but we must know the Lewis structure of that particular molecule. Now we will calculate again the formal charge on the remaining oxygen atom. So I am going to simply make the modification. Okay, so we are going to calculate the formal charge, calculations of formal charge on the oxygen atom, which is marked as a number 3 here. Oxygen atom, its atomic number is 8, so its electronic configuration is 1s2, 2s2 and 2p4. So again we know that 2s and 2p will contribute to your valence electron 1. So total number of valence electron for your oxygen atom will be equals to 6. Okay, now total number of non-bonding electron. Now you can find out the total number of non-bonding electron, and that will be equals to, there is a 3 lone pair of electron on this oxygen atom, therefore the total non-bonding electron will be equals to 6. Okay, now the total number of bonding electrons, again we know that this nitrogen and oxygen form only single bond, therefore its total number of bonding electron, therefore the total number of bonding electron will be equals to 2. And again apply this formula and find out this answer. You already have the values. So value of your VE, that is valence electron, equals to 6 minus non-bonding electron, there are 6 non-bonding electron, minus 6 minus 1 by 2 into bonding electron equals to 2. Therefore 6 minus 6 will be 0, and again 2 divided by 2 will be equals to 1. So therefore this will be equals to 0 minus 1, and its formal charge will be equals to minus 1. Therefore the charge on your oxygen atom marked as a number 3 will be equals to minus 1. This is a calculation of formal charge on the oxygen atom. Now after calculating the formal charge on the each atom, we can represent the Lewis structure with the formal charge in such manner. So the Lewis structure of N2o molecule with formal charge is N with the lone pair of electron with the triple bond, and we know that the oxygen atom, which is marked as a number 2, have the 1 positive charge, and this nitrogen atom, which is bonded to your oxygen atom with the 3 lone pair of electrons, have the minus 1 charge 1. Okay, so this is the representation of your simply Lewis structure with the formal charge, and simply by knowing the Lewis structure we can find out the formal charge on any atom in molecule or the polyatomic ion.